Moments. When discussing moments, we are talking about the turning effect of a force. The classic case is a seesaw, so consider the diagram below as a rudimentary seesaw. The weight of the seesaw beam itself will act vertically downwards on the pivot, and this will be countered by a normal reaction. So here's the weight, here's the normal reaction, and these would be equal in magnitude, and therefore we would have a situation of equilibrium. Since both of these forces act directly at the pivot, they will have no turning effect. But consider this force. It would produce a clockwise rotation, the magnitude of which would be F times D. Note this applies provided the force is perpendicular to the beam. Thus, this force could be balanced by this force over here. It has half the magnitude, but it's at twice the distance. And if we do a half F times 2D, that's equal to FD. But note this one is pushing clockwise, and this one is pushing anti-clockwise. The seesaw would be in equilibrium as forces up equal forces down. The R would adjust as we just add extra forces. So the R is not always equal to W. In this case, we would have these extra forces pushing down. R would be equal to W plus F plus a half F. The resultant moments are zero. As we discussed, this one produces a moment FD clockwise, and this one produces a moment FD anti-clockwise.